Hello, and today we are going to be talking about section 6.4, trapezoids. So, the shapes we talked about so far, the opposite sides on both sides were parallel. In the case of a trapezoid, though, what's going to happen is you're just going to have one pair of opposite sides that are parallel to each other. So instead of all the sides being parallel, in this case, you just have one pair that's going to be parallel to each other. So what's going to end up happening is because these lines are parallel, these angles on this side are going to be same side interior or consecutive interior angles. Remember, we learned about that in chapter 3. If they are consecutive interior angles, they're going to add up to 180. Same thing over here. These are going to be consecutive or same side interior angles. So again, they're going to add up to 180. So what we're going to say is that consecutive angles are supplementary to each other. So supplementary, again, just means that they add up to make 180. Well, we also have something special called the isosceles trapezoid, which, just like with an isosceles triangle, that means two sides are equal. So what's going to happen is that the non-parallel legs are congruent to each other. You can see that over here in this trapezoid. The left and the right side happen to be congruent legs. What's going to also happen is the diagonals are going to end up being congruent to each other. So this diagonal and this diagonal are going to be congruent. The base angles are going to be congruent to each other. You see where this is going. So these two angles down here happen to be congruent. Likewise, these two are also base angles. So these angles happen to be congruent to each other. And similarly, just like with a regular trapezoid, the consecutive angles are supplementary, which also means the opposite angles. If this angle and this angle are congruent to each other and this one are supplementary, well then this angle is also supplementary to the other opposite side. So lots of facts that pop up there. Base angles are congruent, consecutive are still supplementary, meaning opposite are also supplementary, and the diagonals are congruent. So let's take a look at our first example that we can look at on this practice here. So, in this one it says, find the measure of angle R, which is going to be right here. So my goal is to figure out how big that angle is. Well, what I'm going to need to do is figure out the value of X so I can plug it in. We just said that in every trapezoid, these consecutive same side interior angles are always going to be supplementary to each other. So what I know I need to do is take those two equations and combine them into one equation and then set it equal to 180. So I'm going to put them one on top of the other so I can add them together. 12x and 7x is 19x. Positive 3 and negative 13 is negative 10. And again, we'll set that equal to 180. I'll add my 10 to both sides. Cancels out here, and I get 19x equals 190. That's going to give me a nice, beautiful answer. When I divide by 19, I get x equals 10. So again, we didn't want to find x, we wanted to find r. So now that I know x equal to 10, I need to plug it in over here. So I'm going to come over here and plug this in. So 7 times 10 minus 13. So I get 70 minus 13, which is going to give me 57. So the measure of angle r is equal to 57 degrees. For example 2, this time I moved up to an isosceles trapezoid. That doesn't change what we do here, though. If they still give us two consecutive angles, even if it's a isosceles trapezoid, the same thing is going to happen. I'm going to do the exact same thing to solve this. I'm going to add these two angles together. 10x minus 33 added together with 4x plus 17. So here I get 14x. Over here I got, well, negative 33 and 17, so negative 23, negative 16. And again, set that equal to 180. So I'll go ahead and add my 16 to both sides. 14x equals 196. And if I divide both sides by 14, I get that x equals 14. Again, we want to make sure that we're being cautious, because if you just circle that answer like I just did there, you would not have the correct solution. You did not finish the problem. So you want to make sure you go and read what it asks. It said find the measure of each angle. So now that I know this is 14, I need to plug it in. So I'm going to start by plugging it in up here. 10 times 14 minus 33. So I get 140 minus 33. And when I subtract that, I get 107. So what I know is angle J is 107. Again, because of the properties of trapezoids, we know that if angle J is 107 in an isosceles trapezoid, the other base angle, since JK is a base, trapezoids have two bases, kind of weird. JK is a base and ML is a base. Since JK is one of the bases, both angles are 107. Similarly, you could plug in 14 down here if you wanted to, but you don't have to. We know that these are supplementary, so what number would you add to 107 to get to 180? Well, I know that's going to be 73. 73. Again, if you need to see that written out, it was 180 minus 107 gave me 73. Again, M and L are base angles because they make a base together. So if this is 73, this is 73. And there are all four angles found. All right. Trapezoids also have another property that we have to talk to. So this is kind of like an extra set of notes. Mid-segment. So trapezoids can have this mid-segment drawn inside of them. What the mid-segment is if I find the midpoint of AD, in this case E, and then find the midpoint of BC, in this case F, you can connect that to create the trapezoid's mid-segment. The mid-segment joins the midpoints of the non-parallel side. That's what that's saying. From this, a couple things happen. One, if AB and DC are parallel, which they have to be if it's a trapezoid, well, what ends up happening is EF is also parallel. So all three segments are parallel to each other. And what ends up happening with EF is that EF is going to be directly, the measure directly in between the length of AB and DC. Whatever measures in between those two is it. In other words, you're finding the average of their lengths. And whatever the average is how big EF is. So to do that, we add together base 1, which is AB, and base 2, which is DC. And since we're adding together two things, think about when you did mean in Algebra 1. When you do mean, you take and divide it by the number of things you're adding together. So in this case, I'm adding together two things, so I'm going to divide it by 2, or we multiply by 1/2. It means the same thing. So to find EF, we add the two bases together and then divide it by 2. So let's take a look at how that might look in a problem here. Here I jumped right into using some algebra for it. So my two bases are 38 and x plus 14. So I'm going to add those two things together. So x plus 14 plus 38. And then to find the average, I divide by the number of things I'm adding together, which in this case is two bases. When I do that, I'll get the length of the mid-segment, which is 5x minus 19. So what I'm going to do here is I'm going to start by multiplying both sides by 2. We're going to have to multiply the 2 to both things over there. These will cancel. I can combine some like terms here too. X, 14 and 38 would combine together to make 42, 52. Okay. On this side, we'll distribute the 2. So 2 times 5x is 10x. 2 times negative 19 is negative 38. And now we've got this nice little multi-step equation to solve. Subtract x from both sides. Cancel, we get 52. Equals 9x minus 38. And we'll add 38 to both sides. That's going to give us 90 equals 9x. So my last step, divide by 9, cancel. I get x equals 10. Again, let's make sure that we're doing this right. It says find the length of YZ if YZ is the mid-segment. So I need to take this and plug it into the length of YZ. So 10 times 5 minus 19, so I get 50 minus 19, which gives me 31. So my final answer is that ZY or YZ is equal to 31. And in our last example on this page, find the length of WX if UV is a mid-segment of the trapezoid. So again, we're going to add together the two equations that we know. The two base angles or base lengths that we know, x plus 7 and 6x plus 5. I did it backwards. 6x plus 5 plus x plus 7. And again, we divide those by 2 and set it equal to the length of a mid-segment, which is 8x minus 3. So again, I'm going to do this kind of in two steps. Let's combine these like terms, and let's multiply by 2 on both sides so that we can get the 2 out of there. So these cancel. 6x and x makes 7x. 5 and 7 makes 12. On this side, distribute that 2 in. 16x is 8x times 2, and negative 3 times 2 is negative 6. And then we'll go ahead and solve this here. So I'll subtract my 7x from both sides. That cancels itself out. My 12 comes down. 16 minus 7 is going to give me 9x. Bring down my minus 6. And then I'll add my 6 to both sides. I get 12 plus 6 is 18. And last but not least, divide by 9. And I get x equals 2. It says find the length of WX if UV is the midsegment. So I want to plug this in for WX. It looks like WX is this x plus 7 up here. So we're going to plug in 2 for x. So I have 2 plus 7. That's a nice easy problem. It's 9. WX equals 9. That's going to be it for trapezoids. Those two major things, the midsegment theorem and those properties. Let us know if you have any questions. Thank you all so much for watching. Bye.